Now, the next section, it's about limit as x approaches infinity. Okay. Now, first and foremost, do you know what feature we're talking here? What feature on a graph that we're talking here? What kind of asymptote? Thank you. It is horizontal asymptote. And now, I was telling my Calc BC students that they don't have to worry about this too much because their level of difficulty is so much higher, so they would take care of this. But Calc AB students, they suffer from this. What do they suffer? They suffer from the simple fact that when they look at limit as x approaches infinity and they do not know it's about horizontal asymptote. Okay? Now, what I am about to share with you, it's two different approaches on finding out horizontal asymptote, if there's any. Okay? There's a conceptual approach and there is an arithmetic approach. Or the algebraic approach. You need to master both. Okay, not just one. You need to show both. You need to be able to do both. So first one, let me go ahead and go over the conceptual approach. And my professor from Calculus 1 taught me this, and it's so darn useful. So the argument is very simple, and we can do this within seconds if you are really good at this. So the conceptual approach is this. All right. Well, x is going to be a gigantic number, right? So would the -1 matter here? Nah. Would the +5 matter here? No. So now you're down to just 3x over 2x, which can be then reduced to? And the answer is 3 over 2. Done. Okay. Because ultimately, when we are investigating about horizontal asymptotes, we are trying to see, hey, who is growing faster? Is it the numerator or denominator? And what we see from this limit is that, wait, hold on, this rational function right there, 3x minus 1 over 2x plus 5, they are both linear. So they are the same type of function. No one is outgrowing each other, outgrowing the other. So that's why it's going to be just 3 over 2. But now, you cannot show this to your teacher on paper. All right? You cannot just scratch things out and say, well, here's the answer. That would be great if you are looking into if you're looking at a multiple choice question. For response, you do the following. Well, can we just substitute the infinity into the x's? We say no. Why not? Because you will end up with infinity over infinity, which is, well, so-called indeterminate form. So what do? We say, hey, let's go ahead and divide by the greatest power. And I'm going to say that there is an asterisk when I say divided by the greatest power. And I will tell you what the asterisk is for later on. Okay? Well, what good does it do if you divide by the greatest power? Well, the greatest power, it's 1, right, for the x. So we just divide by x. So we got 3 minus 1 over x, 2 plus 5 over x. So we do this so that when we plug in infinity into x's, and by the way, you can skip this step if you are clear, because that just becomes 0, and that just becomes 0. So you get the same answer, which is 3 over 2. Easy peasy. Okay. All right. So conceptual approach and the algebraic approach. Make sure you have these two approaches ready. All right. And now we say, hey, Mr. Chan, I got another question. Sometimes there's a square root. Okay, no problem. Now, how do we do the square root? Conceptual approach. Well, the conceptual approach will be like this. Well, x is going to be gigantic, right? Does the +1 matter? Nah. So you have square root of x squared in the denominator. Cool. So the x squared, square root, they're gone, right? Now, it's not going to be an important thing right here, but I would like to emphasize this now, and that it's when you take the square root of x squared, you might have heard of even, odd back in Algebra 2. If you did not, it's fine. Just to keep in mind that is whenever you take the square root of a number, it ends up to be just a number by itself, no negative. Okay? It's not going to be a problem right here, but it will be a problem in the future, near future. You cancel each other out. So the answer is 3. 3 seconds. 10 seconds or less, you got your answer. We good? All right, now, how about the algebraic way? So the question would be, do we divide by x or x squared? Because I said that we will divide by the greatest power, right? What do you think? We will divide by x. Why not x squared? Well, because if you take the square root into account, the power, it's really just the x. Okay? Now, and I'm about to do something, but before I do this particular action, I would like to make sure we are all comfortable with a simple fact. I have a number 2 right here. Do you all agree that number 2 is equal to square root of 4? Yeah. Yes, right? So if we slide a number into the square root, it's going to be squared. All right, now, so what's going to happen? Well, the numerator of the complex fraction would simply be 3. That's easy. What about the denominator? Well, that x right now, it's outside of the square root. We got to sneak this x into the square root. So what's going to happen is, are you okay that the x is now x squared? Because it is now inside the square root. Okay? Just like how I said 2 is equal to square root of 4. That means x is equal to square root of x squared. So some people, they are not comfortable with this manipulation, but we say, hey, you know, it's x on the outside, so it's x squared underneath the square root. So what's next? Well, 1 plus 1 over x squared. And when you plug in, when you substitute infinity into x, or x squared in this case, it becomes 0. So your final answer is just 3 over square root of 1, which is 3. We good? Algebraic versus conceptual, side by side.